Consider three investments, each with a 6.5 year investment horizon, but each with different equity multiples. We can start by taking a look at the numbers behind these three hypothetical investments. We'll begin our evaluation by comparing the equity multiple, which is a ratio of cash returned to cash invested. Investment A begins returning capital immediately, which allows compounding through reinvestment of earlier cash flows. On the other hand, this investment provides the lowest equity multiple of 1.68. Investment B features a partial return of capital in the middle of the investment and provides a higher equity multiple of 2.2. Investment C has the highest equity multiple of 2.5, but returns no capital until the end of the 6.5 year period. As you see, basing your decision on the equity multiple alone may not be the best way to go, considering that you will want to either reinvest your distributions or use them to fund your lifestyle. Let's compare the internal rate of return to find out how these investments stack up. Were you surprised to see that investment A had the highest IRR? Although investment C returned the most money to the investor, there was no time to reinvest. So the 2.5x equity multiple is all that the investor will receive. On the other hand, investments A and B provided a combination of distributions and time to reinvest. Let's take a look at what happens to you when you reinvest your returns at the same rate of return as the specified IRR. Let's spread the distributions out horizontally so that we can track the returns from reinvesting each distribution. Now let's add the subsequent returns from each distribution reinvested at the specified IRR. Considering reinvestment, this investment returns a total of $290,000, which after subtracting the initial investment of $100,000 yields a profit of $190,000. Considering reinvestment, we arrive at an equity multiple of 2.9x versus 1.68x, considering only the cash returned. The first distribution of $2,000 represents an 8% preferred return. Let's take a look at what happens to the first distribution when reinvested. That $2,000 nearly triples over the next 25 quarters and is worth $5,730, assuming reinvestment at 17.2%. The last $2,000 distribution in the penultimate quarter is worth only $2,086. This is a striking example of the time value of money. The $80,000 received after 2.25 years more than doubles over the next 4.25 years. Now let's go through the same exercise for investment B. This investment returns a total of $256,000 with reinvestment, which, after subtracting the initial investment of $100,000, yields a profit of $156,000. This yields an equity multiple of 2.56 with reinvestment, which is significantly higher than the equity multiple of 2.2 calculated on cash returned alone. The third investment provided no time for reinvestment of distributions, and so would provide the same result for equity multiple either way. The purpose of the foregoing exercise was to illustrate that to achieve the return specified by the IRR involves reinvestment risk. The assumption is that you are able to expeditiously invest the returns at the same rate of return as the calculated IRR. While less expressive than IRR, considering the compound annual growth rate, or CAGR, can help us to further understand what's going on under the hood. With the original investment, nearly half of your returns predicted by IRR come from reinvestment. Whereas IRR assumes the full power of reinvestment, CAGR underestimates the power of compounding by ignoring compounding entirely. Investment B does benefit somewhat from the additional time to reinvest. Investment C has the same CAGR for both investments because there was no time to reinvest. Investment C has the same CAGR regardless of whether you consider reinvestment, because there was no time to reinvest. In general, I would recommend using the IRR because reinvestment is powerful. And also because when it comes to paying bills, cash flow is essential. This exercise is provided mainly as a contrast to IRR, so as to better understand IRR in a context. This exercise is provided mainly as a contrast to IRR, so as to better understand IRR in context, and also to understand why metrics differ according to the situation. Next, let's calculate IRR using Excel. if all of your cash flows occur annually, you can use the shortcut formula IRR. Let's start by typing equals IRR into a cell. Next, we'll enter all the cash flows for the values.
When you want to calculate IRR, but your time frames are not precisely annual, you can use the XIRR formula. To do this, we'll enter an equals XIRR, parentheses, enter the values, which are the cash flows, comma, and then the dates. Close it off with a parenthesis, and you're done.
Next, I'll cover the criticisms of IRR. IRR does not take inflation into account. To do this, you would need to perform a
Discount
cash flow analysis, which requires choosing an arbitrary discount rate. As mentioned previously, IRR assumes that you can reinvest your returns at the same rate of return as the IRR of the As mentioned previously, IRR assumes that you can reinvest your returns at the same rate of return as the IRR of the original investment. It may be difficult to do so for smaller distributions, and there will always be some delay. IRR also includes significant advantages. IRR simplifies comparison across different investments because it does not require an arbitrary discount rate that would hamper apples-to-apples comparisons. Of course, that doesn't mean that you can take projected IRR values from different investments with different operators without a grain of salt. You'll still have to do your due diligence. You alone must determine what returns you actually expect to receive, given all available information. Now let's turn to the formal definition of IRR, which is the discount rate that sets the net present value of future cash flows to zero. Let's go through what each part of the formula means. R is the discount rate we are seeking to find by trial and error. The Greek sigma means that we are going to sum over all of the time periods from n equals 1 to the final time period. C sub n is the cash flow during period n. When you're done summing all of the discounted cash flows, you will subtract the initial investment, which is denoted by C sub 0, because it occurred at time equals 0. Remember that we are seeking the discount rate that sets the net present value of future cash flows to 0. That was just the first iteration. If the net present value was positive, increase the discount rate and repeat. If the net present value was negative, decrease the discount rate. When your net present value is tolerably close to 0 within a reasonable epsilon, congratulations, you're done. Of course, in this day and age, no one would actually do this with pen and paper. The good news is that you know enough to program a computer to do this in case you had to include IRR as part of a larger algorithm. Catch you on the flip side.